Hello everyone, nice to be with you on this new webinar which happens actually today outside on the fields. As you can see, we are not in our usual demo lab anymore. This time we are really outside where I will try to show you or to give you some hint how to acquire hyperspectral data outside. Before to dive into the live demo, I would like to introduce myself and also I will introduce Specim. And after that, of course, you will see the live demo, how to use a camera like this. About myself, I am Mathieu Marmion, working at Specim for 13 years and nowadays as a lead application specialist. And as you can hear, we have a bird who is happy about it. Also, I'm working at Specim, which has been founded in 1995, about 29 years ago. And during all those years, we have delivered more than 10,000 hyperspectral devices all around the world. All around the world where we actually have distribution networks in many countries, which you can contact to acquire our devices. We also have our own offices in many places. So we have some in the United States, Spain, Germany, China, and of course in Oulu, in Finland, the headquarters, where we are actually right now in somehow our garden. So here, this is the field, the tree we are going to shoot with the cameras. Since 2020, we are part of Konica Minolta, and here we are. So, about our offering, what we can offer you for hyperspectral imaging like this on the field. Here you recognize an FX camera, this is the FX17, and this is mounted on a rotary scanner, the RS10. This time the sample is not moving, but the camera is moving like this, rotated around an axis like this, and acquiring line by line the scene which is behind me, so again the tree which is just behind here. On this rotary scanner you can mount an FX10, an FX17 and also a sphere camera. This rotary scanner, we have actually two models. We have the RS10, which can support up to 10 kilos, and we also have the RS50, which can take up to 50 kilos. 10 kilos means it can carry FX10, FX17 without any problem. For the sphere camera, which is more heavy, it is actually better to take the RS50. Also, you could use our thermal cameras, the FX50 and the FX120, in the field on the rotary scanner, but because of their weight, you need to use the FX50. And because they are thermal cameras, this time you cannot use the usual radiometric calibration to convert the data, the raw data, into radiance, but this time you have to use thermal calibrator black bodies. I'm not going to demonstrate those cameras now in this webinar, but if you have some question about those ones, please do not hesitate, contact us, and then we will answer to your questions. So, back to what we have here. We have the FX17, which is mounted like this on the RS10. When you're in the field, you have to think as well about power requirements. Here what happened, we have the FX17, which is connected to a multiplug, and we also have the RS10, which is here also connected to a multiplug, this one connected then to a wall socket. Sometimes on the field you cannot have a wall supply like this, so you need to have like something you can carry. I recommend to use an aggregator that you can put some gasoline and then you can just put it on and then you can get the electricity you need. You don't need to have a lot of electricity, but you need to have some. Also, be aware that to control this, you need to use a laptop on which I have the software Lumo Scanner, which is installed. This is exactly the same software that you are used to use in the lab. For example, when you use the FX camera on the 40x20 or the 100x50 scanner, this is exactly the same software, but it's just that here it controls the camera and also this rotary scanner. Then about the illumination. When you are on the field, you have to consider illumination. To use artificial light, it's not necessarily possible. It's not easy to carry with you. And here I will use the sun. It's better if you have a clear day. So basically, if you have a clear sky, it's perfect. Today, I must say the weather is not perfect. In Oulu, we are having a blue sky, but also a little bit of clouds. And keep in mind that cloud is like having a water filter. So you have like a water filter between your light source and also the samples. You know that water is having strong absorption at the end of the VNIR spectral range, so around 900 and 1000 nanometers, around 1200, 1400, 1900 nanometers. So it means that when you have cloud on those bands, the data will be actually quite noisy. But okay, this is how you have to do, or to take into account. Another thing that you have to take into account, this is the white reference. So for the white reference, if you want to convert your radiance data into reflectance, you need to have a white tile. In our portfolio, we have different type of offering. We have this one, which is about 10 by 10 centimeters and supplied with the IQ camera, which I will explain a little bit later. And we have also larger one, like this one, which is 43 by 43 centimeters, which is perfect when you're on the field and your target is further away. So you have to be careful that your white reference is part of the image that you are going to take. And then when you have your data, you can look at this white reference. You can then characterize what is the incoming light with the radiance data. And from there, you have the possibility to convert the radiance data into reflectance. Reflectance, which is a ratio of reflected light compared to the incoming one for each of the bands. Also, I mentioned about the IQ. The IQ, this is another camera we can offer. It has all the power which is in there. So basically you have the battery which is there, it's battery operated. You also have the memory card, so you don't need basically to have a laptop that you have in here, so it's easy to carry on the field, and it will be part also of the live demo in the second part. You heard me talking about radiance data. You may wonder what it is. When you are on the field, you cannot control everything. You cannot have a white reference which is covering the full field of view, but you need to characterize the incoming light. When you use a camera, just recording data, it will record raw data which are affected by the incoming light, and also the sensitivity of the camera. The sensitivity of the camera is affected by the transmission of the optic and also the quantum efficiency of the detector. So the raw data are affected by that. But then, if you want to give a physical meaning to those raw data, you can use what we call a radiometric correction, which will then convert the raw data into radiance. And radiance, they have a physical unit, which is in milliwatt, divided by steradian, nanometers, and square centimeters. Once you have those radiant data, which have a physical meaning, then you can extract the characteristic or the properties of the incoming light, and then you can expand it to the rest of the image as using the formula I mentioned, what is the reflected light compared to the incoming one. So then you can really get your reflectance data out of the radiance data. One could say, well, you could do it directly from the raw data. Not really, because if you do it from the raw data, you have to make the assumption that actually the response of the full detector, each pixel is exactly the same one. Before to dive into the demo, I would like to highlight one thing, still again about the illumination. When you place your white reference, you have to place it on your area, on your scene, in a place which is representative of what the light is over your full area. This is an assumption you have to make. It is true, it is not true, that's how it is. When you're on the field, you cannot control everything. So try to have your white reference located in an area where it's representative of everything of the white reference you have all over the place. You can choose to have several white references as well in your imaged area, and then you pick up the one you want for the data normalization. Okay, I think I spoke enough about the system, about who we are, what we do. I think it's much better now to act and to actually do the actual demo. Now we are ready for the live demo, and I will start our acquisition software, which is LumoScanner. Here, this is the same software as we are using basically to control the camera and acquire data as well on our lab scanner. Notice that now I have an FX17, which is between 900 and 1700 nanometers, which is mounted on our RS10, as I have introduced previously. Keep in mind that we have two types of FX17 camera, we have the camera link version and we have also the Gigi version. Here I use a Gigi version camera, so that means that it can be connected directly to Ethernet adapter of my laptop. If you will have a camera link camera, either Sphere, either FX10 or either FX17, it's possible to use a Pleora converter which is converting camera link signal into an Ethernet one, which could then be connected again to the laptop. So here I will connect with that one. You are used to that. I find here the device. I can connect it. Then I check the calibration pack is the correct one. Again, I'm not making a tutorial about Lumo scanner. We have video for that, but just to show you how to use it. I will record the data here on the E drive. Remember that we recommend always on our laptop or computer to have two hard disks, one for the operating system and one dedicated for the data. In that case, this is one external one, USB 3 SSD connected to my laptop, and the data will be recorded there. Then I can give a prefix to the data, and then I will connect to the Rotary scanner. So here we have the Rotary 10. I will connect on it, like here. It always takes a few seconds to connect like this to the scanner. It is done. And then I move to the end. As you know, we have as option with Lumo Scanner and Lumo Recorder some plugins. And here I will use the one for radiance. I will check that the data could be saved in float. Notice that here, in this case, I cannot use the reflectance one because the white reference will not be covering the full field of view. And the 1 hour plugin in Lumo Scanner and Lumo Recorder requires to have the white reference covering the full field of view. So here, that's why I cannot use it anyway. So we'll have the radiance step in between. Here, this is the user interface you know about the software. And here, we can rotate like this the scanner, and we can see appearing the trees that we want to image. Notice that here we have actually some area which are saturated. I'm not surprised, it's because behind the trees there are actually some wall with some covers made of metals. So this is basically what you can see. It is in red here, it means that it is saturated. And again, this is something really you can take into account in the field. If you're interested by the tree, that's fine, then try to maximize your signal over the tree, but if the surrounding is saturated, it doesn't really matter because this is not what you're interested in. Anyway, so here you can move like this your system, and before to actually make the data acquisition, you need to adjust the focus. So the way to make the focus is the same as in the lab scanner. You try to find an area where you have some dark and also some bright area, and you can tune the focus by turning the lens like this. And when you start to see that it's at the right place, when you see the transition between the dark and the non-dark area is pretty sharp, as it is now, that means that it is on focus. And this is the way you do it. So basically you look, for example, at some cable, power lines or things like this, and this is a good way to do it. Then about the integration time. You remember you need to have the white reference, which is somewhere as part of your image. Hop, we see it. I went a little bit over. We look at it again. And then we put, this time, the spectral profile here over the white reference. Then we look at it. We know that it corresponds to 6 pixels because remember here, this is the spatial axis, the spectral one, the spatial axis. So here we look at it. And here we have basically data which could be recorded with an integration time of 19 milliseconds. So that means that over the white reference we have about 912 digital number as a maximum signal. One could think this is not a lot, and this is true, I have to say, but the tree that we are imaging is now on shadow, and the sky that we are having is actually a little bit cloudy. So of course I could increase the integration time. So here I could put a frame rate which is much lower, for example 30 frames per second. And then I can have an integration time, for example, of 30 milliseconds. Then of course I could have a better signal ratio. I can do that, but that means as well that the scanning speed will be much lower because you know you have to match the rotation of the camera with the scanning speed of the scanner, and you understand that all of that, they are connected. If you have a frame rate which is high, it means that you have only little time between your frame, so that means the exposure time is actually low. But if you have a low exposure time, it means that you have a low SNR, and it means also that the camera can go faster. But you have all those things to take into account. But the good thing with the Lumo scanner, what you can do, when you want to adjust the scanning speed, you can choose one option, which is a field of view, and depending on the lens you are using with your FX camera or with your camera in general, you just input here the field of view and it will compute automatically according to the exposure time, according to the frame rate, sorry, what is the scanning speed. So here we can make a preview, and the camera is actually rotating, and you can acquire your image like this. So this is basically how it looks like. It looks like this. And I think the data as such doesn't look bad at all in terms of focus, in terms of signal to noise ratio. Notice that here the band I use for fast RGB, they are exactly where the water is not absorbing. So it's more like in some area where I have the best signal to be able to see something. The way to use Lumo scanner here with the rotary scanner is exactly the same one as with the usual 40 by 20 or 100 by 50 lab scanner. So you can define here where is actually the start of the measurement by moving like this. So here we can say that we would start the scan somewhere here. Target start, set. Please take it, yeah. And then target stop. We go over the tree, we have the white reference, and I think we can stop here. We have the saturation with the building, but it doesn't really matter. And then we define it like this. And then again, we can make a preview to be sure that we are recording the right thing, like this. So you see the use is actually pretty simple because you have quite good automation about computing the scanning speed, defining the start and the stop of the scanning area. So I think it's pretty straightforward. Okay, then we are soon over. Yeah, we are here. That was just a preview. Then you can set up also the workflow. So here you cannot acquire a white reference as it is done typically, because typically, you know, you can define where the white reference is starting, where it is stopping, and so on. But here you cannot do that because you have white reference which is part of the image. You can do that only in some certain cases. For example, if you are in a museum and you want to measure a painting and you manage to have the white reference which is a side of the painting and then covering the full field of view. So then in that case, you can use this in the workflow to say the white reference is starting from one place, stopping in another one, and then you can then measure your area. But then it's a special case where actually you have the view which is not that large. Okay. Then we are ready with this. We are ready to acquire the data, and I will call it field because we're on the field. I do record. First, it acquires a dark image, as you saw, and then it actually acquires the data. It's a little bit windy, so that means that the branch and the leaves, they are moving a little bit, but not that badly. Here we have the white reference. The scan is almost over. So remember that with this camera, we have 640 pixels per line. And here we arrive to the end where we have the saturation over the building. The data is acquired. Just to be sure that it looks good, we can open Insight, which is our processing software. Here, I will open the data. Data are here. Here we go. I open it. Then I make a rotation. And to me, the data look fine. I can zoom in it. I can change a little bit the dynamic to see a bit better, like this. Like this, yes. Then we can make a selection. and we're going to check how the spectrum looks like over the white reference. And remember that this time I'm looking at radiance data, and then I can look as well as the signal over the leaf, like here. Okay, now I think we are ready for the next data acquisition. When we have seen the data, we're looking good. They are actually quite proper. In the next stage of this live demo, it will be first IQ data acquisition and then how to convert those radiance data into reflectance. Now here we have the IQ camera, which is the one really made by Specim to be used on the field, or where actually you cannot bring the sample to the camera, but you need to bring the camera to the samples. The camera is like this. We prefer to mount it on a tripod because this time the scanning mechanism is included in the camera. So behind the front objective, which is having a field of view of 31 by 31 degrees, you have actually the spectral camera which is moving behind like this, the front objectives. So this is how it does look like. So this is now mounted on the tripod, and the way to operate it is as follows. So again here, this is the tree we are going to image, and you can see the white reference, so we are going to image somewhere here. Be aware that with the IQ camera you have the possibility to record the white reference as part of the image, or then you can pre-record it and then you can remove it to take the image without the white reference in, which is somehow masking one area of what you could be interested in. So the way to use it is as simple as that. So basically this is mounted like this on the tripod. Then you can choose like this to have actually, yes, the device which is now connected. Yes, the catalog is empty because I did not record anything before. Sorry, like this. Then is what I was explaining. You have the possibility to acquire the white reference simultaneously, or then it's going to be custom. In the case it's custom, you pre-record it in advance here. By the way, all those informations are available already in our videos, which are about how to use the IQ camera. Then here I can start the pre-recording, and you can adjust the focus. So here it's a bit challenging, I have to say, because it's pretty windy. But here you have the possibility to zoom in a focusing area like this, and where you have all those orange peaks, which actually are here to depict if you have like a strong gradient between dark and bright area. When you see those like this, that means that you have a focus which is pretty good. Then you can also adjust the integration time like this. So when you have the green area, it means that it's actually recommended here. I have to say typically it a little bit overestimate the integration time, so I like to put it at the minimum. And then it gives you an idea about what is the integration time for each of the recorded frame and also for the full image. So here it will take about 46 seconds. I just press the button, and here you will have the data recorded like this. Notice that it's very easy to use the camera with a touchscreen like this. You also have the possibility to control the camera remotely, either by having your laptop, your computer, or the camera on the same Wi-Fi network. So you have the possibility to do that. Or also you can have, like here, the camera connected to the laptop with a USB connection. With this camera, you also have the battery, which is included here, as well as the SD card. So you don't need to have a lot of accessories with you. You don't need to have a laptop. You don't need to have a lot of big luggage of whatever you need. You have everything which is here. Once the data are acquired, you can look at it here. You can keep or discard the data. Here, I want to keep it. I can define where the white reference is located. It is here. And then the data are going to be normalized. Here, notice that I will get reflectance data without going through the step of radiance. Why we do that here with IQ? We do that because we consider that once you know how each pixel covered by the white reference are reacting, it's exactly the same as all the other pixels of the detector. We consider the pixel response of the detector being homogeneous over the full detector chip. With the other camera, we are not so certain about it, we prefer to have the radiance conversion also to homogenize everything. So here, we don't need to do it, so we can directly export like this the white reference signal all over the detector. And here, we can see the image, which is captured. We can look at the spectrum, and here, already from here, sorry, I don't want to delete it, I want to see the spectrum. And here already we can see the spectrum which is appearing. Notice that today is a cloudy day, so that's why we notice that around 900,000 nanometers the spectrum is rather noisy, because again the cloud is like a water filter between your light source and your sample, meaning that it absorbs, so you have very little of data or signal. Thank you. So, as you have seen, we have acquired the data, and we acquired them with the IQ camera and also with the FX17 here, which is on the field. For the IQ data, if we open them directly from here, we can see that data are already in reflectance. When we started the scan, the leaf, they were actually not moving at all, but then here it started to be windy, so you obtain this kind of phenomenon. But already from here, if we look at the spectrum, we get the reflectance data. So here that's the one of the white reference, close to 1 everywhere. So you can see actually that it's a little bit overestimated. That happens when you have this type of shadow. So when the white reference is located in a more shadow area, you can obtain these kind of things. And remember that today we had a cloudy weather, so that's why the signal between 900 and 1000 nanometers is very noisy. This is coming from that because remember the cloud is absorbing the incoming light here at this wavelength. But then if we look at another area, so for example here on that leaf, we can recognize the spectrum pretty nicely, that here with the chlorophyll and the red edge, which is rising like this around 700, 750 nanometers. Data look good with IQ. They look good as well with the FX17. And here they are again in radiance. So in radiance, if I look at the white reference, this is the signal we have, and here you can see what is the scale. It's microwatt divided by square centimeter, divided by steradian, divided by nanometers. So this is really like a physical unit. But then some people, they are used to work with that. So for example, in remote sensing, but also you would like to get the reflectance. So basically to know what is the reflected light compared to the incoming one. Unfortunately, in Insight, we don't have the possibility to do that right away. So what I will do is that I will use NV. So I will open NV. And you know I'm a dinosaur, so I still use the classical way, the classics interface. I need to open the dataset. So the dataset was here. And I will open directly the radiance dataset, which is just over here. So here, this is the dataset, just like this. And if I want to make like this the radiance conversion into reflectance, then I need to make a region of interest, like this, over the white reference. Oh, sorry, I did not select the right one, of course. Delete the region of interest, and then I want to have a rectangle like this. I select it. Then at Specim we made an add-on for NV like this, and I will make a normalization. So to do that, I need to input the file. So that was a raw file, which is here. So again, I pick up the radiance one here. I select it. I actually don't need to input the dark because it has been done already, but I will still select it, but it doesn't have to be. So the output directory is going to be the same place, here. Then I will convert the data into reflectance using a subset of the image as a white reference. I use a white reference which is reflecting at 100%, And then from here, I would like to get the reflectance value in floating points like this. I do not necessarily want to create a JPEG. Data are in radiance units, so I don't need to take again the dark, because the dark has been removed when we were already converting the raw data into radiance. And then I will also remove those ones. Okay. Then we have the spatial subset, which was the region of interest that I just made. I take it into account, like this. And then we will get like this, the normalization. And here we then have the normalized data, which appear just here. And if I look at the spectrum, again, here, we see that we have reflectance data. So you look a little bit noisy where we have the water. But then if I move where we have the grass, like this, and then I can make an average, for example, 3 by 3 pixels. Like that, tuck. This is basically the reflectance of the grass, like this, over, or like this. And if we look at the white reference, we have here a reflectance which is equal to 1. And here again, it looks really noisy in those wavelengths because this is actually where we had the water absorption. I can open that as well in Insight. I open it here. Then I can go directly to the Explore view. I can fetch where I have the data set, which was here. Here. Then it was saved in Capture. Then I take this one and I drag it here, and then it will open automatically. Here I can make the rotation, and here again I can make some selection, and those are again the reflectance value. So this is what we have. I'm back here. I hope you like the live demo and it answered a lot of your questions. Anyway, so if you have more questions, if you want us to make a demo, measure some samples, or if you need a quote, please do not hesitate to contact us at info@specim.com. You can also consult our website, specim.com. We will be happy to come back to you. So now we are done somehow for this session. Let's go back to our studio where we can start our Q&A live session. So, by the way, so now I'm going to go through the questions and the question you ask, and actually it's nice to see that there has been like quite many. So if you still have some questions, please go on with it, ask, write them, and I will start with the first one. How slow we need to move in the field to collect hyperspectral imaging data, and is it better if light condition in the field can be controlled for hyperspectral imaging? What you saw in the video, we made the rotation of the scanner so that we could keep actually the aspect ratio. So you don't need necessarily to scan slower to then merge the frame to improve the signal to noise ratio. This is one strategy you can do. If you're a bit short in light, if you see that your signal to noise ratio is a bit short, is a bit poor, and you want to increase it without having a scanning speed which is too slow, or having an integration time which is too high, I mean. So you can do that, but it's not necessarily needed. But if you do it, just choose a factor which is like an integer. So for example, if the scanning speed is x, and if you want to scan too slow, use, for example, like half a x or 1/3, so that after you can have a merging, which is much easier. And then you were asking about the light. Well, when you're outside, you cannot always control, you know, like the illumination. Typically it is the sun, but you may have clouds, like actually we had during the day of the record of this session. So then you can compensate by using halogen, by using like artificial light, you can do that. But yeah, you know, like if you are indoor, like in a museum, you have to use this type of artificial illumination. Outside, try to use a day where you have no clouds, so basically a sunny day. What are the minimum distance between camera and target when using AFX camera? So here we are talking about the airborne camera that you can put on a drone. And as Harry mentioned, actually, we are going to have a webinar about those devices in December. I don't remember exactly the date, but it's in December, early December. And we will go more into details about the usability of those. So about the question, in fact, for the AFX10, to the best of my memory, it's 7 meters, and for the AFX17, I think it's 10 meters. Can we attach FX17 under the ground-based vehicle? Yes. In this case, the camera will be in a steady position and the vehicle will move to get the image. Actually, we had people doing that. So already putting, like, you know, the camera on the arm of a tractor, for example. You have to consider the illumination, because if you have like a big mounting shed somehow to protect the camera from rain or whatever, then it will create some shadow, so you have to consider that as well. But we have seen people indeed putting the camera under the vehicle like this, and then you can move. One approach you may consider as well with the FX17 is that instead of having a lens in front of the slit of the camera, you can put some fibers. We have this possibility, and then you can have 30 channels. So then from the camera, you can have 30 channels, and then you can put them along an arm. For example, you could have a side or behind of your tractor, so you can go on the field. So there are those possibilities. What is the price estimation of an N17 camera? So you mean here, I guess, FX17 plus a tripod scanner. So here I invite you to consult, to contact our sales team, info@specim.com, and here we can come back to you with a quote. I'm not going to give any price here on this webinar because we have competition watching us as well. Please confirm what is the range of the portable camera, so meaning the IQ. I can confirm it is 400,000 nanometers as it is for the FX10. We have a Specim IQ from 2019. Does it also support remote control through Wi-Fi using the laptop? We need to check what is the firmware version. From 2018, I think it has already the correct firmware version. If not, it could be upgraded, and then this support could be done. You could see it already from the user interface of the IQ, where you have the connectivity. Then you can see already if you have it available from there. Where can we get the Specim NV plugin? So here, this plugin, typically, actually, we do not sell it. It's something we use as an internal tool. Be aware that in the coming release of Insight, there will be this possibility to make a selection like this. Having said that, if some of you are stuck here and you don't know how to make a normalization of radiance data by making like this a selection, you can contact us, and then we will see what we can do with this plugin. Be aware that it's not supported in every NV version. So yeah, but yeah, it will come in Insight as well. What is the max resolution of image? Can it record the video? Here, it depends what you mean by resolution. You mean temporal resolution, because after that you ask for video. So I will say, no, this camera is not suitable to record video. It records a frame at once, and you could see from the IQ and also from the FX10 or FX17, which will be placed on a rotary scanner, it takes time to acquire an image, so it's not really suitable to make any video. Then if you mean about max resolution, if you need about spatial resolution, it depends on the camera. For example, with the IQ camera, you have 502 by 502 spatial pixels. With the FX10, you have 1024 along the line, and then it depends how much and how long you are scanning. For the FX17, it is 640 spatial pixels per line. And then if you think about the sphere camera, it is 384 spatial pixels. Will it be possible at some time point, that the Rotary Stage RS10 is not homing back to 0, but going to the start point of the measurement instead, for example, 20 degrees? No, it's always coming back to the 0 position, but I don't know why you will need that it will come back to the start position of the scan. So you could, for example, rotate the scanner so that it goes to the 0 position when it is a start, or I'm not sure of what you need. But no, it doesn't have this type of things. But be aware that we have a plugin, which is here for Lumo, which is a time lapse, which will allow you to set how many images you need to take and what is the time between each image. So imagine you have a scan, beep, beep, then you wait a little bit, next one, and so on, and so on, and so on. And you can actually specify how many images needs to be taken. Will I be able to analyze a solid forest wall in this way? Yes, you can do that. So for example, you can image whatever you want. So now I had a tree which was located about 5 meters away from the camera, but you could imagine that the camera could be located 20, 30, 50, or even like 100 meters away from the forest you want to measure. So yes, you can have the rotary scanner, then you can have the tripod, the camera on it, and then you can acquire your data. This is not a problem. Hi, I have not understood why the IQ camera does not need to compute the radiance before computing reflectance. Could you clarify that? Yes. It's because, you know, when you have your detector view, which is my hand, basically, you have the spatial and the spectral axis here. When you have the white reference, which is covering only part of the image, it means that only for some of the pixel, you know what is somehow the reference value of what is the incoming light. And then you need to make the ratio when you want to have the reflectance, what is reflected compared to what is income. And here you can make the ratio only for those ones. For the IQ, the response of the detector is really homogeneous. So if you know here what is the signal of the white reference, you can export it easily for all the pixels. But for the other cameras, for the FX10, the Sphere, and the FX17, the response of each pixel of the detector is not exactly the same. So if you know it for those pixels, you do not know if those pixels they will respond exactly the same way for the white reference. So how can you make the ratio? So the way to do that is to first convert the data into radiance so that you can really get a good image of what you have, and you can give it like a physical meaning to have the radiance unit. And once you have done that, then you can make the ratio what is reflected to what is income. So this is the reason. It is mostly because of detector uniformity and that each pixel responds the same way. For the FX17, why were you not adjusting frame rate and exposure so that the DN of the white ref spectrum was closer to the, no, actually the maximum, close to the 2048 maximum. So maximum is 4096. First of all, because it is a 12-bit. Then, yes, you can do that. I could have adjusted the integration time that it could be higher, that it could have been, I don't remember what it was, maybe 5 or 10 milliseconds, but I could have had it higher. I could have doubled it or multiplied by 1.5. Then the rotation, the speed of the rotation scanner would have been like twice or 1.5 slower than what it was. But yeah, you can do it. You can do it the same way. Here, I think it was enough. The camera is having a good signal-to-noise ratio. For the demonstration purpose, I think it was fine. But I agree with you. You could increase the exposure time so that actually you get the best of the dynamic for the data. When you selected scanning speed, calculation method, field of view was the value of scanning speed in the setup. Field of view was the value of scanning speed in the setup menu automatically updated. Yes, if you select field of view and you actually point out what is the field of view of the camera in terms of degrees, automatically it will match with your frame rate what should be the scanning speed. So with a rotary scanner, I recommend this way. Whenever we turn on our Specim IQ camera, it warns us for a calibration error. We have calibrated as it is described as a tutorial, but the calibration error still occurs. What to do? Okay, so if it says the spectral calibration has an error, so basically it means that the camera may need to be shipped back for inspection. So here you need to contact our support team, and here you can go to our website, and here you will have instruction how to issue a RMA. Because typically what it do with IQ, you have a spectral reference tile, which is like orange typically, and then you have a white one. And then there is an automation in the IQ so that when you take a test image like this, it will look at the spectrum of the orange tile, sorry, and then it will compare it to what it should be theoretically. And if the deviance is too big, that means that there might be an issue with the spectral calibration. Issue with the spectral calibration, it means that the camera may have dropped or gluing have failed or something like this. So it might be good to contact our support team and then they will help you what to do with it. Sometimes the reading is saturated after data recording with IQ, even though on a sunny day. If you are saturated, you mean to decrease the integration time. Basically, it is what it means. So if you have a sunny day, so basically you may have a lot of light, so indeed you need to have a short integration time. If you have some saturation, still with a minimum integration time, then you may consider to use, like neutral density filters that you can put in front of the front objective of the camera to decrease the light which is actually entering the system. But, sorry, basically it's a question of adjusting the integration time. Regarding objects that are emitting IR radiation, just as black body, for example, I assume you don't need to use white ref to get the spectrum, right? No. When you work in emission, you cannot use a white reference because the white reference is here only to make reflectance data conversion. So when you work in emission, you need to convert the raw data into radiance, and then here you need to have the radiometric calibration. Can the greenhouse cover cause problem with the image acquisition? For example, the light. Yeah, so for example, if you have a greenhouse and the walls are made of a kind of a plastic, of course the plastic has a certain transmission. So if you don't have any artificial light, but you are using the sunlight, so between your light and actually what you measure, there is a filter somehow, which is a roof, and that may have an impact. So you need to take that into account. So of course, if you have the white reference, which is located in the same conditions, that will be taken into account, and you may have like the absorption somehow of the roof will be taken into account into the normalization, but that's the thing you have to consider. Typically, you may have some absorption about 900 nanometers, like you may have some small peak. So if you normalize taking that into account, that doesn't have a big impact, except that the SNR will be a little bit worse. But it's good to be aware of all those things. I have a lot of problem with Wi-Fi connection. EduRoam is not accepted. I don't know what is EduRoam. Connection over smartphone Wi-Fi hotspot is very unstable. So in practice, only a domestic Wi-Fi can be used. I typically use my phone. I have to say that I have a phone, like I put as a hotspot, and typically I'm using that one. I don't have a huge problem with it. You could use another type of Wi-Fi, like the one that of your building and things like this. That's typically work for me. The one in buildings, you have to be careful. There is no kind of firewall to prevent any connection like this between instruments. But for instance, with my mobile phone, it works. With iPhone, I have seen that there could be some issues. But if you don't have an iPhone, that should be fine. When I'm using IQ in the field and there is no cloud, there is too much light even with very short integration time. Should I use some kind of shade? How it will affect the image quality? We have seen, for example, people using like shade to prevent to have too much illumination, to put like, for example, like a white piece of fabrics made of cotton, for example. Cotton has pretty good transmission. To have some shadow like this, that's one way to do. Or as I say, you could use some neutral density filter that you can use in front of the camera. That could be one way to proceed. Of course, when you are making, I was thinking that when you are making the normalization, you have to think about it, but when you have the neutral density filter, it is taken into account. So no, sorry, I was saying something which was not relevant. But you can use either the shade or the neutral density filter. We need to verify the acquisition of the spectral camera recording using the Lumo recording software. The camera is a FX10CE. Specifically, we will need to verify the LEB value and the consequent recorded delta. I verified that the significant output is made up to 3 files stored in the capture folder .hdr.log.raw. The last one is the largest, about 14 megabits. Yeah. How can I read this file and verify significant colorimetric variation? So here basically you need to open the data. So yes, you have the data, they are saved in the NV format. And the NV format, indeed, it includes the header, which tells you the size of the image actually, and also the spectral calibration. And then you have the actual data, which is a .raw. Sometimes it is also a .dat. And then the .log is just for you to see if there was any acquisition issue while you were acquiring the data. So here you need to use a software which is suitable to open NV data, and we have Insight for that. And actually in Insight, we have the possibility to convert the spectra obtained with the FX10CE into LEB values. So Insight will be the right tool. So here I invite you to contact info@specim.com to get a quote for the Insight software. How the transformation of raw intensity data into a radiance look like practically? Is it the factory or user process? It's a bit both. So basically, when you have the raw data, you need to have a file to convert the raw data into radiance. But this file, we generate it at Specim. To do it, we have an integration sphere with already known reflectance inside and also already known illumination. Then we put the camera in front of it, and then we compute or we make a calibration matrix which can convert the raw data into radiance. And this needs to be done at Specim. So if you need to have the radiometric calibration for your camera, I invite you again to contact Specim for that, and we can make the calibration for you. Okay, focusing is a weaker step for FX10 and FX17 acquisition. Please provide focusing grid as included accessories. Well, when you work in the field, you cannot always have it. So it is a bit difficult to have a focusing grid on the field because you need to adjust the focus at different distance, and then you can do it the way I was doing it with a rotary scanner. So you have some pattern, you look at it, and then you adjust the focus with that. With the lab scanner, with a 100 by 50 scanner, a focusing grid is included. With the 40 by 20 scanner, it's not provided, but typically I advise you to take a white object or white paper, for example, and to put at the top of it something which is black, and then you see that the transition between dark and white is as sharp as possible. Where can plugins be downloaded? Which plug? You mean maybe the time-lapse plugins. It cannot be downloaded because it has a cost. So basically, you need to contact our sales team, and then they will make you a quote, and then we can provide these plugins. Can you suggest a neutral density filter for the IQ? Thanks. Here, we can give you what is the size of the filter threads that you can put in front of the IQ camera. Actually, I can check it just now. Just give me a second. For the IQ camera, we have the possibility to put a filter. Yeah, the filter thread is M40.5 times 0.5. And then typically we recommend to use or to check those from Tor Labs or those of Edmond Optics, and then they may have some. Why is there an assumption that the spectral response of the IQ is uniform and the effect is not? FX has a one-dimension array of pixels, so the entire image is acquired through the same pixels. No. You have to consider how the camera is working. So you have actually like a detector, so it's one line. That's true that you have a slit, and then the light is entering only with this one line. But then you have the diffraction optics, which is coming, And then, depending on the wavelength, the light is deviated downward and upward, and then it is projected over a 2D detector. And then you have the spatial axis, and then you have the spectral axis. And then this is your detector. And some of them, they are super homogeneous in terms of each pixel, how they will answer, they will respond to a certain excitation. This is the case of the IQ, but for the FX10 and also for the FX17 and the sphere camera, this is not the case. Do we have more questions? If not, thanks. Harry is telling me maybe one more.
It's in the Q&A.
Okay, we have the Specim IQ camera and we would like to buy a polarized filter. Some recommendations, thanks in advance. Again, we don't sell those filters ourselves, but Edmond Optics, Torlab, Medops, they may have some. So Roya as well. So look at those websites and there you may find, I'm sure, like a polarizer. Hello, how the environmental characteristic affects the measurement and what should be taken into account to collect proper image. When you think about field data acquisition, the first thing coming to my mind will be if you have clouds or not, or if you have like a kind of a filter between your light source and your actual scene that you want to record. So typically, if you have like a clear sky, it's fine. But if you have some cloud, it's like having a water filter between your light source and your samples. And water has some absorption. So that means that on those bands where water is having absorption, but also the atmosphere, so it means that there, basically, you will have a really low signal-to-noise ratio. And actually, you could see it from the data we recorded. You know, water has strong absorption about 1,450 nanometers, and you could really clearly see on the spectra that there the SNR was not the best. So you have to take that into account. Another thing was to think about the homogeneity of the illumination. So if you have some area where the light is not the same everywhere, you may put some white references in different places. What else? You need to think about having a white reference or to use a gray reference. If, for instance, like your samples are much darker than the white reference, that's something to take into account. Yeah, that's what comes into my mind. What will be the pixel value range in hyperspectral imaging for each layer? So basically, it depends on the camera detector you are using, but with the FX10, FX17, and also the IQ, this is a 12-bit camera. So that means that raw data, they are coded for each band between 0 and 4095 digital numbers. There are also some cameras which are coding the information over 16 bits, but yeah, then it is up to 65,500 if I recall well. But yeah, this is what we are talking about. Then the next question, how much power does the FX17 and RS10 use? To the best of my memory, the FX17, it's about 24 watts. And the RS10 is less, I think it's around 5 watts. So this is the power requirement for those. Target start and stop. So this is in Lumo scanner. Are this rotation angle? Yes, from the origin. How accurate? Oof, I don't have the data sheet of the rotary scanner into my mind, but it's a stepper motor, so it needs to be checked with the manual. I don't have those numbers into my mind, so we can send you the manual later to look at it. How long does battery last in the field? Expected number of hours. So here we are talking about the IQ, I imagine, and actually I don't know the lifetime in hours, but I know in terms of acquisition. So when the batteries are fully loaded, you can take 100 hyperspectral cube with the IQ. So this is how we size basically the battery. Can you co-register data from two cameras mounted on the same tripod? How do you account for spatial distortion due to the rotation? Did you use a LiDAR before to correct? Okay, let's take the three questions one by one. Can you co-register data from two cameras mounted on the same tripod? We don't do that because actually cameras that you mount on the same tripods, they do not necessarily have the same spatial resolution. So if you will put, for instance, an FX10 and an FX17, one is having 1024 spatial pixels, one is having 640 spatial pixels. So that means, first of all, the sampling, the spatial sampling is not exactly the same. But there are still possibilities, for example, that in your scene you could put some mark, and then based on that you can make some resampling, some interpolation, and then to make a match. We do not do that, but we know that there are some possibilities to do it in MATLAB, and we have as well a distributor who has made a solution for that. But ourselves, we don't do it. Keep in mind, we also have the Phoenix. So here the Phoenix, it collects the full spectrum between 400 and 2500 nanometers with a single front objective. So then it solves the issue. How do you account for spatial distortion due to the rotation? We don't, and that's something important, especially if you have something in front of you which is flat. So, but the thing is that you know that the distortion is everywhere the same. So what's possible to do is to measure a target and then to apply a corrective matrix on that. We don't do it either, but this is something that we are aware of. When you work on the field and you have something which is in front of you not flat, the effect is not that important. But if you want to measure a piece of art where you know you have the sample which is not that far and then this is flat, this is true, there will be some distortion. Did you use LiDAR before to correct? No, we don't use LiDAR. Is it a problem if my integration time is so high that it captures the target correctly, but the white reference is saturated? Yes, it's a problem. It's a problem because if you saturate the white reference, basically you don't know what is the incoming light. So when you do the reflectance, you cannot really get good results. So here I would advise you to do two things. The first could be to use, for example, like a gray reference style. Instead of having one with a reflectance of 100%, you can use one with, for example, 50%. That would help. The second one to use will be to use a dual integration time. And that's something that we do, for example, when the sample is really dark compared to the white reference or things like this. So basically you acquire your data with a certain integration time and the white reference with another integration time. Then you can normalize like this, and then in your normalization formula you have to take into account those integration time differences. We have a technical note for that if you wish. You mentioned that cloudy weather will produce a noisy measurement around the 1000 nanometers band, 970 to be accurate. Will variation in humidity of a subject will produce similar noisy effect? So here you have to consider is what I was saying, like when you have a cloud, it's like having a water filter between your light source and your samples. So that means that this water filter will absorb the incoming light. So that means that you will have less light which is coming. So that means that somehow you will have less reflected light as well, but in terms of dynamic range of your detector, the signal to noise ratio will be worse. So then if you have humidity in your sample, it might be what you want to measure actually. So measuring the moisture is something you may want to do with the camera, and then you will see the effect on the spectral signature. I think this is what you were asking for. That's my understanding. Hello from South Florida. Hello from Finland. Does Specim offer student opportunity for graduate students to learn how to use their equipment? To learn how to use our equipment, we have actually like training videos and we have training materials. So I recommend you actually to contact us and then we will give you. Also, if you are located in South Florida, be aware that we have our own employees in the United States and they will be really happy to help you. So we have training material for you there. I have a very high stray light effect with Specim IQ at the beginning of the spectral between 425 nanometers. How can I correct this? The stray light between 400 and 425 nanometers. Typically, you have it when you use halogen light. Why is that? Because the halogen illumination is super rich in the infrared, but is really poor, on the other hand, on the blue part of the spectrum. And at the top of that, you may have samples which do not have a high reflectance in the blue, but a high reflectance in the red. So when you take that into account, yes, indeed, between 400 and 425 nanometers, you may have some stray light. How to take that into account? Maybe to use another type of light source. So if you look at the video again for this webinar, you could see that when I was using the IQ under the sunlight, which is much more homogeneous, spectrally speaking, between 400 and 1000 nanometers, you could see that I did not have the stray light between 400 and 425 nanometers. Then you could use, for example, LEDs, because LEDs as well, it's like the sunlight, is much more homogeneous, it's much more balanced, spectrally speaking. So this is what I would recommend to do. And if you want to minimize the stray light as well, try to not to put bright samples next to the dark ones, because then you may have a stray light effect. Is there a smartphone hyperspectral camera add-ons in the near future? Who knows? So it will be interesting. I don't know if you want to take picture with your friend of your holidays in the hyperspectral mode, but that's a possibility. We don't know. So, but you know, hyperspectral cameras, they get smaller. I could imagine that multispectral will come rather quickly, but hyperspectral, I'm not sure. What bands do you recommend for RGB when shooting with FX17? It depends. So if you want to shoot outside, you should take some band where you have actually signals. So if you put your false RGB bands, your RGB bands on the water absorption band, you will not see anything. So put them where you have more signals. So for example, 1100 nanometers, 1300, 1500 or something like this. So put where you have some signal. Don't put them where you have the water absorption or the atmospheric absorption. Then if you don't work under sunlight, but you work with artificial illumination or in the lab, just choose whatever you want because you will have signal. Is dust likely to produce noisy measurement for agricultural application? Well, if your samples is covered with dust, this is true that at the end you may measure more the dust than your samples. So dust could be a problem, and that you should take it into account. So if you have dust in the air, when you make the measurement, so between the camera and between the samples, so if you have like this dust on the column, let's put it that way, again, it will have an impact as it has an impact for you, for your side. But be aware that there are things that you may think will be disturbing and actually are not. If you are thinking about smoke, for example, if you want to detect a fire, the NIR and sphere spectral range are suitable to see through smoke. So it depends. But dust, it's more something which is physical, so that could be like a problem. How the vegetation survey is possible by Specim IQ by the tripod like you used? Or basically you can put the IQ on a tripod, you can measure like this plant. Be aware that you have as well a timer, so you can put the IQ and to wake up just before to acquire frame, you can acquire multiple images. So you can make some survey like this, but this camera is really well used for this type of application. When you want to work on the field or when you want to work in greenhouses, that's a perfect camera for that. Which model is good for study phenology of Shola grassland and which one is good for mounting in drone? I don't know exactly what is the Shola grassland, but let's say you want to study grass or meadow in general or vegetation. I would say the good model is the one covering the spectral range first between 400 and 1000 nanometers, because from that you can retrieve already a lot of information like moisture. If you have any stress, you can see the red age. You can see also the chlorophyll. If you want to detect more advanced phenomena, like if you want to see some pest, some disease, or if you have a lack of, for example, N, K, or P, then the FX17 could be interesting. But let's start first with the VNR spectral range, so IQ or FX10, and which one could be mounting on a drone. So then I invite you to look at the next webinar, which is going to be about the AFX camera. And the AFX cameras, they are dedicated for drones. The next webinar will be in December. And then we have one which is between 400 and 1000 nanometers, and another one between 900 and 1700 nanometers. If you can't co-register the data from two different cameras in the field, can you do it on a core scanner? It is exactly the same. So basically, the same reason you have different cameras with different spatial resolution. We don't do it, but some of our customers do it. So basically, you need to put some mark, which is part of your image, and then you can make the resampling and the interpolation based on those marks. What is the best source of artificial lighting for your camera, for someone who is collecting data about insect larvae in the lab? It depends what you want to do, what you want to see, but if you want to look at fat content, if you want to look at protein content, you want to measure the moisture level as well, the right spectral range is between 900 and 1700 nanometers. It means the one of the FX17, and here I recommend to use, well, if you don't want to use halogen because you're afraid of the heat, then you can use some LEDs. And here again, please contact us. We can give you some link to some LEDs manufacturer we know for those spectral range. I don't want to give them here because we have competition watching as well our webinar, so we don't want to help too much. How the camera mounting should be to cover 2 by 2 meter square. I guess we are talking about the IQ or maybe about the FX, I'm not sure. So, but let's do both. So if you want to work with the FX camera, so it depends basically on the field of view, the lens that you are having, because with the FX camera you can choose different type of field of view. So then you can choose the right distance depending on your field of view so that you can cover a line of 2 meters. And then you choose rotation that you can have the 2 meter like this. If you want to use the IQ camera, it is a square image. Sorry, I have the cable from the microphone here, from the headset. So then it's a square image, and then it is 31-degree field of view in both directions. So then you just choose the distance so that you can have 2 meters. Are there contacts for employment opportunity? No, not this one, sorry. Hello, I am from Maastricht. Can the camera be used for imaging painting? Can you please show some results? Yes, actually our cameras are used quite a lot for research, for the art. And here, yes, we have material to show, we have publication, we have things to show. So not in now because I don't have it right now, but please send a message and then we will come back to you. We have material for you. For the IQ, is another lens needed for close target and small particles? What is the recommended light source? With IQ, there is no other lens. This is the only one we have, which is now available, which is a 31 × 31 degree, and the minimum working distance, it's about 15 centimeters to the best of my memory, 10 or 15, but I think it's 15. And if you want to work more at the microscopic level, with the FX10, we have actually a macro lens, and when you use it, you can have a pixel size which is about 10 micron. In terms of illumination, you could use halogen, but here again, there are some LEDs available, and again, we can give you some of the manufacturer as recommendation. Could the white reference become saturated due to high exposure on sunlight? Yes, it can. And if it happens, how can we avoid it? By using a gray reference. So instead of using a white reference, you use a gray one. And for example, as speaking, we sell some 50% and 70% reflectance. So I would say this is the best to prevent these kind of things. Is LED lights better than halogen light for HSI? It depends what you want to do, but if you want to measure color, for example, it's important to have a more homogeneous illumination between 400 and 1000 nanometers. And here it prevents to have some stray light, what I was explaining before, between 400 and 425 nanometers. So here, yes, you will have a spectral response which is more homogeneous and a good SNR also in the blue. But if you want to work with high speed, if you are, for example, in the recycling industry, then you want to use something which is really powerful. So then here, halogen will be better. We know that there are also like supercontinuum laser, which is an option. But it depends on the spectral range, because you know LEDs, they can cover easily between 400 and 1000 nanometers, between 900 and 1700 nanometers, but beyond that, it's more difficult. So it depends on your application, it depends on your requirements, what your samples can handle, and yeah, so is it better or not? It depends. What happens if the target area has shadow as well as sunlight? I recommend to have multiple white reference. So you put some at shadow, you put some at sunlight, and then you use different type of normalization, and you choose the right white reference depending on the normalization where you want to look at. This is what I would recommend to do. In the field, what would be the distance that will require atmospheric correction? This is something which is used mostly actually for remote sensing applications, atmospheric correction. So I use it sometimes when I have the sample which is right in front of me. It could be used for that when you cannot use a white reference, you cannot put a white reference style. So one way to do would be, for example, to use some atmospheric correction. And I recall in NV, there is one which is colorized, it's a QAC, I think, the quick atmospheric correction. I think this is the name, the QAC. You could use that one if you cannot have a white reference and you have radiance data. If you want to convert the radiance data into reflectance, you can do that. Personally, I prefer to use a white reference because then it's not based on the model. It's something which is really like, that you can really feel somehow. But yeah, it's a possibility. But I don't think there is a distance because the atmospheric correction takes really into account, you know, the atmosphere that you have between your sample and also to the sun. Okay, so I think I went through this list of questions. Do we have more questions? We have one. Could you please share the email where we are supposed to send future inquiries? info@spekim.com. So this is the right email address, and Harry was really happy to put it there. We come back to the 2 by 2 square meter is to cover the vegetation on the ground, for example, flower strips. So here, well, okay, I would think, for example, to put the IQ from a cherry picker and to measure in like this from the top. I could think as well to put like an FX10, for example, and then from, you know, like a translation stage, moving like this at the top of the samples, 2 meters long, and then you choose the lens and the field of view. This is what comes to my mind for this type of application. Where we can find plugins for Spekim Insight. Well, Spekim Insight doesn't have any plugin, but you mean, I think, Lumo, like radiance, reflectance, time-lapse. You need to contact our sales team because those plugins, they are not for free. So basically, you contact our sales team, again, info@spekim.com, and then they can come back to you with a quotation and everything. I think we are running out of questions. And thank you. Maybe 1 more minute. That's a short minute. So yes, we get another one. Hello, Mathieu. Recommendation in art inspection. We had a question like this before. So yes, it depends what you want to do. If you want to measure like pigments, you may want to use a camera which is more in the visible, which can measure colors. So between, for example, 400 and 1000 nanometers. Or if you want to see the underlayers, then you may want to go with an FX17 between 900 and 1700 nanometers, or even up to 2500 nanometers with a sphere camera. With the FX50, which is a thermal one, between 2.7 and 5.3, you can make also some nice research into art. So yeah, we have different type of camera for this type of things. We have some material, we have some publication based on our camera, so we'll be happy to share with you. Can the system be used indoor where it is not possible to use the lab scanner? Yes, indoor it could be, for example, industrial application. The camera are used for that. Or it could be, for example, in I mean, like in a museum. So, for example, you could put the camera there with a rotary scanner, or you could use the IQ. So this is not a problem. The camera could be used indoor. You need to think about the illumination, but there is no problem with that. Oh, here I have a long question. At our research institute, we utilize hyperspectral imaging technology to conduct annual monitoring of the same stone cultural heritage site. Okay. The most crucial aspect of this process is improving the consistency and reliability of data collection. Okay. Even when imaging is conducted in the same month each year, varying conditions such as weather, solar radiation, humidity can differ, making it essential to minimize this impact. I understand. I believe that developing a standardized protocol that adjusts data based on the environmental condition at the initial imaging time could enhance the reliability of data collection by correcting for changing conditions. Do you think the development of technology is feasible? It's difficult because you have to take into account a lot of parameters, as you said, and when you're in the field, you have to consider indeed that you may have like environmental conditions which are changing. But you need to be able to monitor that. So for example, if you have the white reference, which is always taken as part of your image, it already gives you a good clue about how the environmental condition is. You can see what is the moisture. You can see that already from the data. Another thing you can take into account is to minimize the impact on environmental condition on the sensor. Basically, you can put the camera in a casing, temperature stabilized casing, so that you be sure that actually the detector and the optics, I mean, in general, the camera sensitivity will remain the same. So you can try to minimize those things, like having temperature stabilized casing. By the way, we have like a partner who is able to make one for the FX cameras and also for the IQ, not temperature stabilized for the IQ, but still, anyway. So to put a temperature stabilized casing and also to have the white reference to be always as part of the image to monitor somehow what is the incoming light, to take that into account when you do the normalization. So that's what I would recommend. What is the widest range of wavelengths for multispectral? I'm using for UV and 2IR. Well, basically, we don't make multispectral cameras, so I encourage you to contact multispectral vendors. But we are making a hyperspectral camera, and then the typical sensors are between 400,000 nanometers, 1,000, 2,500 nanometers, 2.7, 5.3 in our case, and also 7.7 to 12.3 micrometers. Given a case, how do you find out quickly which spectral band are most interesting? Is it possible to automate this? Or you could try to use, for example, principal component analysis, and you could use the loadings. So already with the loadings, it can give you an idea which bands are has the most contribution, for example, in the principal component 1, 2, 3, and things like this. You could think about that. You can run some PLSDA as well. It gives you some good clue about which bands are the most important one. And just when you look at the spectra already by yourself, it gives you a good idea which material differ from the second one, spectrally speaking. But in terms of automation, I would think about PCA. Okay. What are the pre-processing steps you suggest? Why the results image is rotated to right? Is there any GitHub repository to see any example code for calculation of NDVI? Let's take it into order. What are the pre-processing steps you suggest? It depends on your application, but it's always good, for example, to use a smoother like a Savitsky-Golay. If you want to get rid, for example, of intensity differences, you could use as well the derivative. If you want to highlight some spectral feature, you could use as well some min-max norm. You could use as well some SNV transform. So those are the ones typically that I use. Why the results image is rotated to the right? I think you are talking about the IQ. Well, it depends, like how the data they have been recorded. So typically with the IQ, you record from the right to the left, but with the other camera, it could be from the left to the right, and then it is displayed like this in NV. So yeah, so it's a bit hard to say just like this, but it depends on your acquisition setup. Is there any GitHub repository to see examples code for calculation of NDVI? I would say use Google for that. You just try to find which type of bands are used for different type of indices. Is there a way to rewatch this webinar? Yes, I think Harry sent the link. Okay, so I would like to thank you everyone. We had a lot of good questions, very interesting. I hope it was interesting for you too, so I will finish it here. Again, thanks for your participation. Stay tuned because there will be the next webinar again about the AFX camera, which is going to be in December. Yes, you can use hyperspectral camera for stain and age detection, but here again you need to look for like publication. But anyway, so I just saw last question. Thank you very much, and I will leave you here. I wish you to have a nice day, and if you have any question, info@specim.com. Thank you, bye-bye.